Hello, and welcome to the Wednesday, September 26th edition of the Cluster API breakout meeting for SIG Cluster Lifecycle. Today's agenda is starting with Siddharth, who's got a question about target cluster status.
All right, thanks, Robert. So I just wanted to kind of bring this topic for broader discussion here. So today, for instance, I realized that the cluster object at the high level, it doesn't have any good way of reporting back the status of the cluster. And please correct me if I've missed something, quite possible. So essentially, my question was around, first of all, I realized that the term ready for the target cluster might have very different potential meanings. The way I was thinking at least was maybe we can break it down into two different pieces. Once when let's say the Kubernetes API endpoints are ready to be interacted with. For example, this will happen when the single master or multiple masters are ready to take the APIs, and this might be the time when the very first step of the bootstrap process happens. And that could be one place where we could actually then report back to the top level object saying that the APIs are ready to go. And then, of course, depending upon this, and then there could be a second substatus somewhere which could report the desired, let's say, number of worker nodes, are those added or not, or are those active or not, and that could be driven from that. But yeah, I just wanted to throw it out and see what everybody's opinion are. So that is the definition of ready. And the second was, again, how and where do we actually show this status? So cluster status, we have an object cluster status today, which does not. I didn't see any specific field, an overall field that could be used to specify this set status. There is, however, a provider status, which is a provider specific status reserved for the cluster level. So do we use that, or do we want to maybe add some additional provider agnostic status fields / objects in that hierarchy cluster status object to represent the state? Thoughts?
Yeah, I think you have a really good point about cluster status not saying that the cluster is ready. I was just poking through the kubectl code trying to see how it decides to say that it's finished successfully. And I think right now it just is sort of fire and forget, where for the most part kubectl applies the API stack to the target cluster. Kubectl applies a machine definition and then just exits and says done, and assumes that those things will show up later without actually waiting for them to show up. So it would be really nice to sort of have a way in the API to signal that, like you said, the control plane is ready and ready to be interacted with, and that the nodes are ready. The other thing that we've checked for in the past and is add-ons, and whether other things that you're sort of adding onto the cluster that you're managing as sort of the cluster administrator are also ready to be used. If you are trying to create a cluster and deploy kubedns to it, it's nice to actually know that the kubedns pods are running and sort of telling you that they're healthy before you say that the cluster is fully functional. And sort of representing some of those intermediate states is actually probably pretty useful. Because then you can say, oh, the control plane's up, but the nodes haven't registered, or the nodes have registered, but the add-ons aren't all reporting healthy. So I agree that's something we should put. I think we should put it at the top level of the cluster status, not in the provider config, so that it's consistent across implementations. I don't know exactly what that status should look like and how we want to represent each of those things.
I completely agree. The add-ons, I completely missed that, but yeah, that's a very good point actually. Just not to sidetrack, but I know there was an earlier discussion around something around the add-on manager. I'm not really sure what the status is, but maybe later on, if we have time, we can. If somebody knows about it, can update. That would be great.
Sure. Yeah, I'll include that at the bottom of the agenda, and we'll come back and talk about that on manager. So I don't know, Siddharth, if you've got thoughts if you want to propose what you think that API for status might look like, or if you just want to sort of put it out there and see if anybody else has thoughts about how they might want to structure that.
I mean, at a very high level, my initial thought around how we can potentially do this was, you modified like the control plane API status. So one is just that, and that could be a representative of whether the Kubernetes API for the target cluster are responding or not, and realize that status. And I think the three different things that you mentioned, right? Whether the nodes that are anticipated are those all added and reported. So this could be some sort of like an enum sort of thing, which could say, nodes are added but not ready, or nodes are added and ready, and some of that combination. And the third could be the add-on, which is actually also important. That the add-ons that are requested, are they all reporting the desired state or not? It kind of reminds me, for example, just to take an analogy here, how Helm, for example, depends, like for Helm charts when you deploy, it has sometimes it has ways to say whether this particular thing is up or not, like some sort of dependency management, and it can report back, well, is this service that I want to deploy, is this really up or not? Something to that effect. I mean, something similar logic we could apply here, and bring down or bring up these three, maybe to begin with, these three granular statuses. And we can probably also think about if you want to break it down, for example, the add-on manager. I mean, let's say if you have 3 add-ons that you wanted to add, I mean, one option could be that we can even break down that add-on status to, well, the 3 things that you have requested, this is what the status is, if needed. But that could be, that could be something useful as well, I think.
Right. Yeah. Because for the machines, if you say like not all the machines are registered and ready, there is another API you can go look at to figure out which ones you expect to be there and which ones have nodes linked and so forth. But right now for add-ons, we don't have an API for those. I'm a little leery of baking that into the cluster API as opposed to making that its own sort of first-class API. To start with. So I think we'll have to think about that a little bit on how we want to do add-ons.
Sure.
I mean, the first thing that comes to mind here is to use conditions, because that's like, if you think about like the way that like nodes start up, they start up and they say, networking not ready. They say, they have a condition that maybe says disk space is full, et cetera. That seems like sort of a natural mapping. When we started working on the cluster API, we were told by Brian Grant and Eric Toon not to use conditions anymore, that they were deprecated. But that was quite a while ago now, and I'm still not sure what the alternative proposed way to represent those status fields are. I think Eric might have mentioned that it was just to sort of put the top level status fields in. So like you said, like the status of like, is the control plane ready, as just a top level field instead of making that one of a list of conditions that are all sort of nested in a condition structure. So if we can sort of identify the key things that we want to use to sort of roll up into like, is the cluster ready, is the cluster healthy status, I think that might be useful, just making top level fields.
Right, and one other thing could be also, just like the cluster level status for the machines and the machines, let's say the machine sets, I mean, we could have like a sub status at those level as well, I mean, for the resources that are under that particular abstraction, or a machine set, things like that. So
yeah, I was going to ask for like for the machines part, what do you think should be keeping that field up to date, right? So when you create a cluster, it makes sense because you say, I want to create a cluster with 3 nodes, and you sort of wait for those 3 nodes to show up. And then you can say that, all the nodes are ready. But then over the lifetime of the cluster, you're going to scale the number of nodes up and down. The autoscaler is going to scale the number of nodes up and down. You're going to do upgrades to those nodes where like the actual number of nodes reporting to the cluster is going to vary over time. And it's not always going to match the target number. So would you anticipate like the one or more of the machine set or machine deployment controllers constantly keeping that field in the cluster object up to date with the status of like sort of the fleet of machines assigned to that cluster? Or the cluster controller would be sort of watching machines and deciding when it thought the machines were all healthy?
For the auto scaling, I mean, I guess, based on the last demo that we saw in the last meeting, I mean, if the auto scaling is kind of done via, let's say, the Kubernetes autoscaler, cluster autoscaler, then it's potentially going to talk to the cluster API and, let's say, the machine sets itself to say, I want to scale up, and, increase the number of counts. So that if that happens, then your front object that's basically right in the center of it will be like the machine set or the machine deployment, right? One of those, and then it becomes easier because then that's what is driving actually the scaling up or scale down. Yeah, but I mean, I would imagine that the machine controller, for example, would be responsible for keeping the status of the current set of machines that it is servicing up to date with the objects, I would say. That's, yeah.
Okay, yeah, I'm just trying to think like the sort of who's responsible for understanding that, right? Because the cluster autoscaler, you can point it at a machine set or point it at a machine deployment. In general, you can have machines underneath controllers at multiple levels, right? You can create a machine set directly, or create a machine directly, or create a machine deployment. And so it's not clear whose responsibility it is to sort of watch all the machines, figure out if they're all in sort of the correct state for the cluster.
So we're doing a periodic reconciliation of the machine objects. Considering a normal cluster API deployment, we're doing that through the machine controller and the machine actuator right now. So it almost seems, at least for an initial implementation, that that's where we would do some type of validation there. Obviously we have to take into account, the health of the node object that's associated with that machine if we can as well. So it seems like it would be actuator dependent based on the current architecture. I think it gets muddied a little bit if we start talking about providing an extension mechanism directly to either machine deployments or machine sets, for example, like ASG-backed instances or things like that. But it almost seems like that machine actuator is the way to go, at least for the current architecture.
So I think that makes sense for detecting whether each individual machine is healthy, right? So, but that's already represented in the machine status.
Yep.
And the question is, how do you roll that up and aggregate it for the overall cluster, right? So I want to create a cluster with 15 nodes. How do I say that I'm done creating that cluster because all 15 nodes exist? And is it different if I create 15 nodes by specifying a single machine deployment of size 15, or if I specify 15 individual machines using separate, machine objects, right? And like, who's responsible for saying your target for the entire cluster was 15? Maybe you take three different machine deployments. Like, each of those individual controllers has its own sort of slice of view on the world and is doing its own thing. But what aggregates them all together and says your set of machines across multiple deployments or across multiple machine sets is all healthy, is finished being created, in the initial case.
Yeah, and this seems like maybe the abstraction that we currently have doesn't quite fit that concept, because the cluster itself the cluster object doesn't actually create or manage the entire cluster per se. It only manages really only common cluster components right now. And potentially, I know we've discussed extending it to also manage the control plane. But as far as I know, those discussions haven't made it, very far to date. So it almost seems like the naming maybe needs to be improved before we, exit alpha to improve that situation.
Yeah, that's a good point. I mean, I guess right now what we have the potential to do, at least I don't think we're actually doing it in Cluster Cuddle, is when you use a CLI to create the cluster in the first place, you do know what your target size is. And the CLI could go and look at the cluster and say, is our cluster reporting the control plane is healthy? And do I have the right number of machines in the cluster? And it could actually do that validation. And so we could, if we just had the status field for, is the control plane healthy as part of the cluster object, then the client side can do the aggregation of the two bits together. I guess what I'm trying to figure out is do we have all the machines we expect and are they all healthy? How would you represent that in the cluster, and who would be responsible for keeping it current, right? Like, it's one thing to set that initially when you create the cluster, but over time, like, how do we keep that up to date? So I think the control plane one makes a lot of sense. I'm just trying to poke at the other pieces of this and see how they fit.
Yeah, I would almost like just completely off the cuff type of vague proposal here. It would seem like what we currently have as the cluster object right now should really be, some other named object to better differentiate whether we're just talking about common kind of cluster components or potentially also extend to the control plane, and then have a separate kind of cluster controller that could aggregate the state across kind of those common objects, the control plane objects, and the kind of sets of nodes that belong to that cluster, to be able to kind of reconcile and expose that level of information.
So another option that we could do, because this topic sounds very similar to the way that similar to the discussion about Docker and Kubernetes health check, where they don't hard code any checks in the runtime or the code itself. They let the user. I know that we're focused on bringing up the cluster, just the basic cluster in the control plane, but we have no idea what that's going to look like in the future. And if we allow the user to specify some custom way to do this health check instead of hard coding it in the code, I think that's another option.
I think that also aligns very well with kind of the brief discussions that we've had around kind of webhook driven provider components as opposed to the current actuator model.
Yeah, so I think to Locke's point, there are a couple ways you could implement that, right? You could have the cluster controller itself, quote, hard code those health checks, because those health checks would be specific to how that cluster is being provisioned, right? And if the notion of a healthy control plane is different for the cluster actuator on Google versus Amazon, it's probably consistent for all the clusters created by that cluster controller on Google, right? And it might vary via versions or so forth, but we can write code to do that, as opposed to trying to specify that health check through some sort of like YAML syntax like we have for pod health checks, right? So I think you can still get the flexibility of having sort of, quote, user-provided health checks, but the way the user provides them is they, plug in their own cluster actuator. And maybe there's a separate piece that we want to break out that is just the health checking piece.
Well, what I was proposing is that we can have both. So, we don't know what these clusters are going to look like in the future. I hesitate to say more because I have other ideas, but that's for the future. But allowing users to also have some kind of rudimentary. They can put in some rudimentary calls that that then we can use. We can shell out and then test it to see if the cluster is ready. "Quote unquote" ready according to the user's criteria. So we can have the the baseline in the actuator, and then we can have additional checks defined by the users.
Yeah, and that might be a good way to handle like the add-on thing I was mentioning earlier. For now, until we have a good add-on API, is if the baseline check is the Kubernetes API server is up, its pod is reporting healthy. I have etcd, quorum, and the health checks for those things are passing. That's sort of the baseline. Like the control plane is ready, but you might install like an additional health check that says and verify that the kubedns pod is running and that kubeproxy is running or something, right? And that could be your sort of poor man's check for are all the expected add-ons there. So that might be like a nice way to do that before we have a proper add-ons API. Okay, it seems like the discussion is petering out a little bit, but I think that there is general agreement that we would like in the cluster object a way to represent the health of the control plane, that there is a potential for breaking apart what we currently call the cluster object. Maybe we keep something that's called a cluster object, but it's an aggregation of the sort of common control plane pieces and the machine pieces. I think that notion could use a little bit more exploring. So I don't know if that's something, Jason, that you're interested in driving, or just sort of throwing out there.
Right now, I'm just throwing it out there. I don't have much time to put something together formal, probably between now and KubeCon. If somebody doesn't pick it up before then, I'm happy to run with it, and I'm happy to assist where I can. It's just time constraints.
Sure, that makes sense. So I think what makes sense in the short term is to at least add some sort of field in the cluster status for, is the control plane healthy? And I think at a minimum, we can then update cluster cuddle to say it's going to take that and wait for all the nodes to be reporting ready before it says if the cluster is up and running and ready to use. I think that's pretty consistent with what we do in like KubeUp, and I think what things like COPS do as well.
Okay.
Go ahead. Did you have another question?
Well, no, I came late, so I hesitate to belabor this conversation. I guess I'll just mention anecdotally that in trying to solve this problem for us, I've tried to stay away from defining some abstract exist or ready, because it's difficult to know what that means. And instead, I've tried to substitute concrete things I can check for. So for instance, if I want to know if the control plane is ready, that means that I want to know that there is an API endpoint for the control plane. Actually, that's not what that means. I don't ever check to know if it's ready, because I don't even know what that means. I check to see if there's an API endpoint, because that's what I need to know to proceed. So I just was going to mention that I've been trying to remove abstract fields that are hard to define and replace them with concrete fields that mean a precise thing. That's what I've been trying to do. On the other hand, what I have found is my experience is people writing interfaces on top of this, they don't like having to have this conceptual indirection to find out what they want to do. And they really do want a ready status field. So what we've done to provide that to them is we've built a different layer on top of the Kubernetes API, which I think is just not a great solution. But yeah.
Interesting. So, I mean, I think we have that field today, right? Today we have the field in the cluster status that is the API endpoint, right?
Yep.
So we have that concrete field today. And I think what cluster cuddle does is it actually fills that in, right? We want to flip that around. So it sort of waits for it to be there before proceeding. And so one way to do that would be to have the cluster controller that fills it in not put something there until it believes the control plane is sort of, quote, ready and available to use and in a healthy state. And that would sort of be the signal that, like, here's the API endpoint, you can start using it, it will work.
So I worry about that a little bit, just because the current implementation that we're looking at for AWS, we're looking at backing that API endpoint by a load balancer. So we can actually set that API endpoint before the control plane is up and ready. And that also allows us to better, when we're provisioning the actual control plane nodes, we can actually use the cluster object to get that API endpoint to use to drive the config for the control plane nodes. So I think we need a separate type of either check to verify that the API endpoint is actually available and responding in the way that we expect, or a separate field to indicate that the cluster provisioning, whatever that means, is complete and other operations can continue. In the case of like the AWS stuff, we know that the necessary networking components, be they the VPCs, subnet, security groups, or whatever, are available, and that we can go ahead and start instance creation. Those types of things.
So my comment was around the naming of the field and the meaning of the field. So if you have an API endpoint, that means you have an API endpoint. It doesn't mean anything more than that. If you wanted to know if the control plane was usable, what you would do is take that endpoint and do a list, for instance. And if that worked, you would say it's listable. It doesn't even really mean that it's usable, right? It just means list worked once. And And so I guess I'm arguing that to the extent possible, we should make the fields as concrete as possible, and not abstract, because it's difficult to know what abstraction means to different people or providers.
So having that API status just like, really just mean that the API endpoint that is there in the endpoints list, is that really, listable, or for example, is it even just interactable, right? I mean, just that concrete, meaning of that maybe one specific field, not essentially like the overall cluster status, but just like API status for the test, could be, is that something that might serve better, I guess?
Right, it's not the overall health of the cluster, and I think that I think it's hard to guarantee the state of a distributed system, right? And so we decouple it, say that we're actually not going to guarantee this about every node. We're going to say that we know this about this particular observation. So.
I think that's kind of in line with what I was saying also, is instead of trying to have like a roll-up field that says the cluster is all happy, if the client says, the control plane is responding, is saying it's happy, the machines are all saying they're happy, therefore if I look across the different pieces I care about, like I can determine that I think everything is happy at this snapshot point in time, right? And maybe that's equivalent to a controller doing that and posting a it's happy field and then updating that, once a minute or something, right?
Actually, I think I like that more. Having the client to determine, like, okay, the control plane, is it ready? The machine sets that I have created or I'm managing, are those ready? And I can determine from that. Yeah, actually, I actually like that better than aggregated rolled up, somebody else rolling it up and trying to take that burden.
Yeah, I think the challenge is striking a balance between what makes sense to kind of roll up and what makes sense to redo each time, because we don't necessarily want somebody having to jump through a bunch of boilerplate code to implement interacting with the cluster API as well.
Yeah, I think that's a good point. And I think we have some of those roll-up pieces already. Like if you're using a machine deployment, that will roll up the health of sort of all your machines into one place, right? So I think you have a couple of places to hook there already. And then the question is, if you want to know, are all of my machines healthy? Is it okay to list your machine deployments and check each individually, or would it be nice to have sort of a fleet controller that's actually looking at all the machines across your multiple machine deployments and giving you an easy answer to that question? I think right now we've gone for the former and said, just look at all your deployments themselves. It's kind of like looking at all your deployments of pods, right? Okay, let's move on to the next thing on the agenda, which is the CRD migration status. So Phil is actually sitting next to me. He's been in Seattle this week. We are working hard on, there he is. Hi, Phil. Getting the code compiling and the test passing and the actual bootstrap part working. The initial cut of the PR, if you looked at the branch a little while back, was like the code compiles, it kind of runs, but the tests are all broken. So I've been going through and fixing all of the tests. And the tests are pretty much all passing now, except for one race condition. And Phil's been working on the deployment part and simplifying the way that we deploy. Right now, at least on GCP, we have a shell script that you run that generates a bunch of YAML files. And with KubeBuilder, we get a lot of those YAML files or equivalents to them sort of for free with the way KubeBuilder uses customize under the scenes. And so we're actually trying to experiment with switching from using like the shell script to generate a bunch of stuff to just using customize itself, because it already has generated some of the pieces, to have that sort of generate all of the pieces we need to add to the cluster. And it seems like that's kind of slick and working reasonably well. So we've almost got sort of deployment of clusters working on GCP. Once we have that working and all the tests passing, we'll go back and try to clean the code up a bit and get it in sort of a reviewable state so people can take a look and go through and see if they have any major concerns about the way the code's been restructured, because a lot of it has changed pretty significantly during the migration / refactor. So any other questions about where we're at or anything? Oh, somebody put a question in the doc about time frame. Phil is here through the end of the day tomorrow, and we're really hoping before he flies back down to California that we are at a good point where we can share progress and start getting eyes on PRs instead of us just hacking on code next to each other. So that's the goal. We'll see if we make it. People keep scheduling meetings for me, so like I'm trying not to go to them. Okay, so next, Siddharth had asked to come back to the add-on manager. So what in particular did you want to know about the add-on manager? What can I tell you?
Well, I mean, last from the last information that at least I recall was something was in works to fully be an add-on manager, and I don't know much detail about how. I mean, where is it? I think it was not really yet publicly released. I think it was still kind of work in progress. So I don't know if there is any updates around that. I might have missed some, but if we can just summarize, that would be great.
Yeah, so I don't see Justin Santa Barbara on the call, but Justin and another engineer here at Google have been working on this internally and are, I think, excited to release it to the community, but haven't quite jumped through all of the hoops to do so yet. So it is still in flights. I think that they have a design. They're very excited to share that, but can't quite do it yet. So it's similar to, I don't know if any of you guys were at or watched the recording of the cluster lifecycle meeting we had yesterday. But another engineer at Google named Josh has been working on a concept of cluster bundles, which is basically a declarative way to describe the components that make up a cluster and grouping them in a reasonable way. And so that's something he's been working on internally for our systems here, and now we've published as open source, and we're trying to figure out how that interacts with the changes we've been making to the Kubeadmin API, and we'll look at how that works with the cluster API and so forth going forward. And I know that Justin again said that the COPS community, he presented that to them recently, and they're really excited and they're starting to adopt it. So it's sort of along that vein of like, something is brewing and we're sort of working on it, and once we feel like it's ready for wider review and we're ready to put it out there, then Justin and Jeff will show up here and talk to you guys about how that works. Or actually, they'll probably show up to the main SIG meeting first, and then I'll drag them to this one also, since it's pertinent to us as well. We also, we have a quote add-on manager in the kubeopt scripts right now, and it's also used by GKE, which is basically a shell script inside of a container. COPS has an add-on manager that uses the concept of channels that they run as part of their cluster. This is one of those things that everybody's definition of add-ons is a little bit different. During one of like the contributor meetups, I think it was at KubeCon Austin last year, there was a breakout session about add-ons, and Tim Hawken and I pulled the audience, before we started, just to ask people how they defined add-ons for their cluster, and everybody who raised their hand had a different definition. So part of the difficulty is getting people to agree what add-ons are, because once we agree what they are, it's much easier to define an API and define how we're going to manage them. But right now, everybody has a very different notion of what add-ons are, right? So if I look at things that we call add-ons today, I see things that are sort of control plane extensions. So things like the ingress controller, which generally runs as part of the control plane, is something we call an add-on. Things like kube proxy, which are per node things that we run, but that are sort of managed with the lifecycle of the node, with the lifecycle of the kubelet, as opposed to user applications. We call those add-ons. Things like kube DNS, things like the metric server. There's lots of different things that we call add-ons, and they sort of are sort of all over the place in terms of where they run and how they're configured. So I think we're trying to distill that down to, what things do we actually want to manage, and how is their lifecycle tied to the lifecycle of the cluster or not, right? So hopefully that's somewhat helpful. And I know it strings you along a little bit in terms of like our thoughts on what we want to do with add-ons, but I really want to wait and let Justin and Jeff present that, since they're the ones that have actually done all of the hard work.
No, sure, that's okay. This update is great. Thank you.
Cool. Okay, and then Hardik isn't here today, but he sent me this. It sounded like he was traveling at the moment, but he sent me this doc to share with people that I just linked from the meeting notes. which is a doc he wrote that I've reviewed already that's called Proposed States for Machines. This is similar to the doc that I put together earlier this year with the sort of state diagram of how we think the machine lifecycle should look. This doc is largely based on the fields that are existing in Gardener today that they would like to effectively upstream into the cluster API so that the machine set controller can actually determine health of machines and determine when to replace them. So I think Hardik's mentioned this in previous meetings with the fields for phases and last operation. And so to make it a little bit more concrete, he created a document where he wrote up what he thinks those fields should be and what the meaning of each of them is in a format that's really easy for people to comment on. And so it would be great if people could take a look at the doc, add questions or comments, and then when Hardik's back next week, we can sort of go over it in detail and look through those and see what people think about either adding these fields to machines to do health checks and deal with the phases and states of machines, or if there's other proposals of how we want to represent the state of a machine. Maybe we can either add that to this doc or create sort of a alternative version of docs if people have other ways they'd like to represent the same information. So again, we don't need to review the doc during this meeting, but please follow that link and take a look if you're interested. All right, that was the end of the agenda. We'll give people a couple of minutes if they have anything else they want to bring up. Okay, all right. Well, I'm happy to end early and get back to the CRD code and try to get that stuff finished. So thank you everyone for coming. We'll see you all again next week. Take care.
Thank you.